Hi, everyone. My name is Paul Morley. I am I'm a professor and director of research at the Vero program at Texas A&M University College of Veterinary Medicine and Biomedical Sciences. And we are joined by our panelists from our recent discussion, BRD, if everyone vaccinates, why is it still a problem? And we had a tremendous turnout, both in person as well as online to that. And you can access the recording for that session, the same place where this is posted. But we had so many questions that we really didn't get a chance to answer them all. And the panelists and I, thought that maybe you would be interested in a discussion of some additional questions. So that's what we're going to do. And we're going to do this in two parts. We're going to have it, we're going to have two parts, approximately an hour each. So this is part one. Just as a reminder, our panelists are Dr. John Ellis, who is a professor at the Western College of Veterinary Medicine and University of Saskatchewan. And he's an immunologist and triple boarded. Sorry, I should say he's triple boarded. He's boarded in veterinary immunology, veterinary microbiology, and veterinary pathology. In alphabetical order, our next panelist is Dr. John Richeson. He's a Paul Engler Professor of Beef Cattle Feedlot Management at West Texas A&M University, and he also supervises management of the research feedlot there. And he has extensive experience working in the production of beef cattle as well as in research related to cattle performance and immunology. And our third panelist is Dr. Amelia Willems, who is the Michael and Mary Cheek Hall Davis Endowed Professor of Beef Cattle Health and Reproduction at the College of Veterinary Medicine at Mississippi State University. And she's double boarded. She's a board certified veterinary internal medicine specialist, as well as being board certified in veterinary microbiology. And all of this group is very well known for their work in respiratory disease of cattle. So what we're going to do is we're going to go through this list of questions, and I will be directing them it'll take a bit of a rotation as to who gets who I direct for first answer. And if they have some add-ons to that, then the rest of our panelists will follow up. So our first question, and these are questions that were collected via Slido during the meeting, and they were ranked in order of likes or votes for how many people thought it was a good question or what a question that they wanted to have answered. And so these are ordered in the ranking of those votes. So among the ones that weren't answered during our session. For Dr. Willems, is there any research into vaccination being used several times before weaning? And I'm assuming that this is, let's limit this to respiratory disease vaccination being used several times before weaning and its impacts.
Yeah, thanks, Paul. Good question. And I guess immediately I'm thinking about beef calves, but that could also apply to dairy calves pre-weaning. Certainly some dairy calves get vaccines before they are no longer being fed milk. So, and we're not sure which sort of population the person who posed this question had in mind, but I'll just say quickly that certainly for both populations, we have some research testing multiple, at least two vaccines before weaning. And we've got some good work that was done several years ago at Oklahoma State University looking at beef calves, showing evidence of benefit of multivalent viral vaccines given two doses before weaning. When it comes to beef calves, there are also some work over the years in different sort of retained ownership programs where cattle that were preconditioned were evaluated and sometimes compared to not preconditioned cattle, showing some evidence of vaccination in sort of a preconditioning type program. I think the bottom line with any vaccination strategy is that when we look at research, we often also have studies that don't see a benefit. So, and recently some work came out that suggested that cattle that got more than one or two doses before weaning might actually do worse, which is really intriguing. And we could talk about some different possible reasons for that. I would say that we don't have very much work along that line, and it's a little bit hard to find groups of cattle that get more than two doses of vaccine before weaning. Um, research hasn't really looked at that in a very sort of systematic prospective way. I think the work that's been done has mostly relied on retrospective evaluation of available data. And so it might be that more vaccines given before weaning are harmful. That was in beef type calves, but I think we really need more work to know whether more than 2 doses is beneficial. But we certainly do have research indicating that at least 2 doses of vaccine given before weaning can be beneficial in both beef calves and in dairy calves.
Thanks, Amelia. The next question, I'm going to
Does anybody else
direct.
want to add into that, maybe, Paul?
I'll ask. Sure. Yeah.
I think no doubt in my mind that preconditioning can definitely promote resistance against BRD. It's a comprehensive management practice, right? That involves lots of different things. And I think there's pretty good evidence in the literature that preconditioned cattle get less sick with BRD than high risk cattle. But I think the question is, and what really needs to be teased out is of all those things we do in preconditioning, what's really promoting the resistance against BRD? And the answer is probably maybe all of them, but they may have different levels of importance. I think the weaning and the husbandry and the stress training that you get with preconditioning can really create resilience in cattle. And the vaccination certainly is part of preconditioning. And certainly that's the time to vaccinate, right? In my opinion, is at the cow calf operation if we're talking about beef cattle before stress occurs, before transportation, before those calves are likely to be challenged with the different viruses we vaccinate against.
And so your answers tie back to just tying back to our recording, right, and our session that we had, which one of the big issues that we had was it's a system that is the system management issue is a large component of our outcomes related to vaccination and respiratory disease, right? Because whether or not they're actually vaccinated before they are shipped or received, and what the incentive for that is, and that was covered nicely in our discussion. So, John Richeson, which respiratory vaccines do you think are most effective when administered shortly after arrival, intranasal or parenteral? And as part of that, do you think that intranasal modified live vaccines are less, and the question states stressful, than modified live parenteral vaccines?
Mhm. Unfortunately, I guess the answer to that question is I don't know. There's very little evidence in the literature. I'm very data driven, and so we all have anecdotal opinions, but if I lean on the evidence in the literature, there's a handful of studies that have been published that compare intranasal to parenteral vaccination, and none of them that I'm aware of show a clear advantage of one over the other. They certainly work differently in that, and you could certainly have theories that an intranasal vaccine is going to have a faster onset of immunity. You're going to get a local response. You're going to get interferon produced that may provide some innate protection against viral replication compared to a parenteral. But the evidence, when you compare the two, there just is no clear evidence that one is superior to another. I do think parenterals have the potential to change things in the upper respiratory tract when you apply live replicating virus in the upper respiratory tract. Lots of things are occurring in that environment, and one could be a shift, whether it's good or bad, could be a shift in the upper respiratory tract microbiome that you're not as likely to get with a parenteral vaccine. The dogma would be that Intranasal vaccines are going to provide better secretory IgA production at the expense of IgG or more systemic antibody response, whereas parenterals are going to give you a stronger systemic response, circulating antibody. So I think of one as being more of a blockade, the other being on board to fight replication if that virus breaches the upper respiratory tract and starts to replicate in the animal. But that dogma is really probably not true. I mean, there's evidence that an intranasal vaccine certainly produces a pretty strong serum antibody titer across different studies. And there's some evidence that a parenteral can produce limited amounts of secretory IgA as well. And so, um, but as far as the evidence of one being better or safer than another, there's not strong evidence either way. I do think giving an intranasal, that's the closest. If I was wanting to make cattle sick and develop a challenge model, I'm going to administer a virus intranasally, right? Because that's the natural route of infection. And just maybe perhaps minority thought process is that with intranasal vaccination, I mean, it's an attenuated virus, but it is live and replicating. And so there's a fine line between vaccinating and unintentionally challenging cattle with the intranasal vaccine.
Thanks, John. What about the other John? Maybe you'd have follow-up thoughts on that?
Well, I think part of the confusion is that, the business of that intranasal gives a faster response. I think that the thing to keep in mind is no matter wherever a B cell, naive B cell is, whether it's, in a lymph node or underneath the mucosal surface, it still has the same kind of kinetics. So you're not going to make antibody be made faster by giving a vaccine mucosally. And so the speed thing probably mostly relates to the interferon response, which again it's certainly not anywhere near as robust an antimicrobial response as the systemic immune response or the adaptive immune response. And so and the other thing to remember is that if an animal is already under some level of challenge, there's a refractory period for the innate immune response. And so I think the business that it's faster is really oversold in terms of any kind of efficacy. And, beyond that, I think John sort of alluded to it in the previous question. There's really no published evidence that I know of that one is necessarily better than another. And moreover, neither is there any published evidence that I know of that intranasal vaccination on arrival does any harm in terms of increased morbidity or mortality.
Yeah, thanks. Thanks, both Johns. It's a chance to shout out to the in the session we talked about two books that are on basically applied immunology in cattle. And if you are like me and you're not an immunologist, and the immunologists start talking about different cytokines and different types of cells, and you have to remind yourself, just remind you that there are a couple of good resources that both of their authors on our panel that have been participated in writing in both of those. So just a reminder that there are resources out there to help you. Next question. I'm going to go to John Ellis for first answer. Are we relying too heavily on antibody titers as a measure of vaccine success in disease when it may depend more on early innate and mucosal immune response for protection, I think is the point. So,
yeah, I mean, I've already sort of addressed that in the last answer, but I think probably the innate immune response, certainly it's important, but I think it's probably oversold in some ways. And certainly, measuring T cell responses is going to be very important for viral infections, especially. And we're still kind of in the dark ages in terms of the cow side measurement of that. So, we keep falling back on antibody titers, but that's at this point, I think, from a practical standpoint, what we have. Certainly, from a research perspective, we can do all kinds of magical stuff in the lab, but making that practical in a feedlot situation, I think we're a long way from that.
I think it is confusing, John, that a lot of the information that comes out of, in particular, company-supported research related to licensing and efficacy. They'll use these different measures, and there's justifications about this is better or that's better in terms of the modified live or Bactrin or intranasal or parenteral, and going to both of those. I think it can be really confusing but I'm hearing both of you. I guess what I'm hearing you say is maybe that saying that dogma that IgA response out of the nasal passage with an intranasal vaccine or cytokine messaging in relation to a modified live vaccine or those kinds of things. It's from an applied perspective that work does not penetrate into the studies about efficacy. Is that fair or?
Yeah, I think generally speaking, and all of us have published on stuff, but the reliance on antibody titers is sort of the default position. And beyond that, at least from a theoretical standpoint, going back to the basic immunology issue, I do believe or think that, the fundamental difference between modified live and inactivated vaccines is still true in terms of the antigen presentation. And so certainly for recovery from viral infections, if you're depending on a cytotoxic lymphocyte response, your modified live vaccines are the way you're going to need to prime or with a special adjuvant. But generally speaking, it defaults to a modified live vaccine, remembering that you're going to get a more balanced immune response with a live agent. And whereas with an inactivated agent, you're going to tend to skew towards an antibody response, which is fine for bacteria, but not so great for viruses. So it is complicated. And you're right, it's confusing. But I do think that at the end of the day, since they're T cell dependent responses that we're measuring in terms of antibody responses, it is a pretty good indication of the efficacy of the vaccine if we measure certainly functional antibody, like neutralizing antibody.
Paul,
Amelia.
Yeah, thanks. You could probably see me jumping down out of my chair here. I just wanted to say that I think that we've always in vaccinology had this idea of correlative immunity. That is, what could we measure in the animal without doing a challenge study that would give us a high level of confidence that they should be protected against infection, right? And for some agents, more in people, we have some things that we know are really good correlates of protection, like rabies titers, right? That's why we get our titers checked, because we know that if you have a certain level of antibody titer to rabies, you're not very likely to get infected. But we don't really know what those are for most of the BRD agents, I would suggest. And the question is, are we relying too much on antibody titers? But we don't even measure antibody titers much of the time. In the studies that are done to license vaccines, as we talked about in the panel, those are based on experimental challenge studies, and Dr. Ellis has more experience with this than me, but that's mostly going to come down to how well the cattle are protected from lung pathology or maybe clinical signs. I don't think any vaccine is licensed based on the antibodies that it induces, but John can correct me if I'm wrong. So I guess what I'm trying to say is that we certainly measure antibodies to tell if vaccines work. And when we do research, we use them as evidence that the vaccine has done something. But antibody titers are not used to license vaccines much, I don't think. And we don't know what are the real correlates of protection, which we would love to know, because we haven't done things like measure CMI, cell-mediated immune responses, very much in cattle. Not much money and time has been invested in trying to determine if, for at least the viral agents, is there some assay we could run that would tell us about the cell-mediated immune response?
Amelia, thanks for capturing what I was trying to say. Yes, a correlate of protection is when we're buying vaccines, we want to understand and know. And you've answered that really well. John, sorry.
Well, just a really brief follow-up, I think is a default sort of potentially low tech way to measure things is virtually every infectious disease that I know of is associated with viral or pathogen load. So probably a pretty good correlate of overall efficacy of a vaccine is simply measuring the amount of live antigen or live agent in the that's coming out in the nose. I mean, that's going to probably give you a very good idea of how well the vaccine is controlling the situation.
Great, guys. You probably saw me step away from the camera real quick, and so those are the two books that I was mentioning, and this is a recording, so I'm not going to put them up for very long. But if you need a refresher on your practical immunology in cattle, those are good resources. So, um, Amelia, this next question is to you. Could our vaccinations be causing cattle to become sick from things that we're not vaccinating against? And I'll let you interpret that, how you're, yeah.
Yeah, so I guess what the questioner might have been asking, at least this is how I interpret, is if we vaccinate for certain things, are we then inducing immunity but leaving the cattle vulnerable to other things that we aren't vaccinating against? Or maybe that we don't have vaccines that immunize very effectively. And I certainly think that's possible. Yeah, indeed. The respiratory tract is vulnerable to infection with a lot of agents. As I think Dr. Richeson mentioned when we had our panel, we don't really do very extensive monitoring for what agents are circulating in cattle these days. A lot of what we sort of focus on is based on our understanding developed decades ago. So there could certainly be things that we are not vaccinating against that could be contributing to some of the BRD we see.
And I've heard it postulated that, that we see some of that with changing patterns of BRD diagnoses and theoretically, therefore, agents. So if we're better at managing, acute fibrinous pneumonia that we would have typically called pasteurellosis mannheimia disease, however you want to put it, then we're more likely to see later days on feed mortality or illness. So mycoplasma or some of the other things that have been going on, but no answers to that I'm aware of. But it's an interesting question. Other comments from people?
Well, it's certainly possible, but I don't know of any, at least from an experimental standpoint, I don't know of any study, or certainly is in my experience, if you vaccinate for BRSV, right, cattle aren't doing something else, right? And so I don't, I mean, in theory, that's a possibility, but I don't know that necessarily paves the way for other agents per se.
Okay, thanks, John. John Richeson, this one comes to you. Where does the increased performance asked of cattle today come into play? Metabolically and physiologically, we ask a lot more of cattle today than we did 50 years ago.
Yeah, I mean, certainly I think we got into the discussion a little bit during the panel about how we've selected for increased weaning weights in cattle. Our cattle are growing faster today. They're reaching heavier weights at an earlier age, and therefore the presumption would be at a lower immunological maturity. And so I think all that probably plays into BRD risk. I think it's a win. I like to think if we have made progress, it's that we have definitely changed the genetics in the cattle population, and we have not necessarily selected for disease resistance through that time period. And so if BRD is about the same today as it was, perhaps we have made some progress because we have these very high performing animals that are strongly selected for growth and they're going through the production system, and we're not seeing a huge increase in BRD through that. As far as related to vaccination, I mean, it's hard to say whether selecting for these growth traits may impact response to vaccination or effects of the vaccine. I mean, vaccines themselves can be metabolically demanding related to that question. So I think it's important to think that anytime you administer antigen that you're you're asking, there's a metabolic ask with that process.
Okay. Any follow-ups?
Paul, I just wanted to kind of throw a couple of their ideas out there. One, in terms of performance, and I may have mentioned this in the panel, but just quickly, I think we should all keep in mind that fat cells have been shown to produce inflammatory cytokines. And so when we are making cattle become more fat, which of course in the feedlot we are, we may be inducing them to be more pro-inflammatory. That hasn't been looked at all in cattle, as far as I know, although I've heard a few people throw this idea out there. So that'll be something that I wish we could look at is, does the sort of fat that cattle accumulate while they're on feed have any impact on their inflammatory responses? And then just kind of on the idea of performance and how that's related to disease risk, somebody reminded me recently that cattle are staying on feed longer these days. And if you just look at a straight mortality curve, it looks like things are getting worse over time, but that you've got to remember that of course, if cattle are in the feedlot longer, they're more likely to die before they leave the feedlot, right? Every day they're in the feedlot, they have a risk of dying. And so the more days on feed, the more risk of dying. So as we think about these things, and, we have quite a lot of BRD in spite of vaccination, it is a little bit of a moving target. That is the way cattle are managed on feed, I think.
Okay. The next question, I'm going to send this to John Ellis. Not all vaccines are the same. What does a good vaccine do?
I think the answer to that's really simple. It reduces disease that's directly associated with the pathogen that's in the vaccine. It's that simple. All the rest of the stuff, measuring all the things. I've spent a lot of time and gotten a lot of papers and measuring various things. But at the end of the day, what certainly a producer or a clinical veterinarian can understand, it simply reduces disease. Not necessarily prevents infection, but if you're using a vaccine, properly using a vaccine, and you see reduced disease, that means that the vaccine's good.
So, from a buyer perspective, right, a consumer perspective, then uh, um, the other is interesting. Bottom line, evidence-based decision making would be based on that, right?
Yeah,
Difference in disease occurrence.
correct. Assuming
Okay.
that, again, there's a lot of assumptions that the vaccine was properly administered, not at arrival, for instance. And so again, I think you have to ask, how are vaccines meant to work, and what are the kinetics of immune responses? But under those sorts of situations where you have the immune system has a chance to interact or act, then look for a reduction in disease. I think it's that simple. And you don't need a statistician generally. I joked about that in the panel, right? You should be able to walk in to a group of cattle who are vaccinated or not and see who's sick and who isn't. I think it's that simple.
Okay. Um,
Paul, I would love to hear John Richeson's thoughts. What makes a good
yeah.
vaccine?
I would agree with that. It's so frustrating that the right kind of research. Well, first of all, unfortunately, a lot of cattle are initially vaccinated the first time in their life when they do arrive. And I think we all agree that's probably not the best timing. But if that's the way it is in our industry, I just wish there was better evidence that I could understand better. It's by if we do that versus if we don't, what is the effect on BRD morbidity and mortality? And there's just not a lot of good studies out there that include a negative control population to help us understand what the benefit is to the way we vaccinate cattle in our current beef production system. I think MLV vaccines are a very unique product of all the products we give, whether it's an anthelmintic or an antibiotic as metaphylaxis or a growth promoting implant, all the things we do at initial processing. An MLV vaccine, in my opinion, can be life sparing. I think in some animals, it has the capability of changing outcome and saving an animal's life. but the effect ranges all the way to probably causing death in an animal. I mean, if anything, we know that vaccines can cause endotoxin containing vaccines can cause anaphylaxis and cause death in animals. And so you have these different outcomes that are possible if you give that MLV vaccine on arrival in a stress immunosuppressed host, from life sparing to actually causing death in the animal. And those two have some sort of balance. I think for the majority of the population, it probably doesn't change true outcome. There's a lot of cattle that are going to get sick, whether they get a vaccine or not. And there's a lot of cattle that are very resilient and robust that they're going to thrive no matter what you do at initial processing. And so I would love to see more research to help us understand the true impact of vaccinating on arrival. I wish, companies or there would be some funding source to do the kind of work, the large population size study that we need to do to better understand that.
Right. So going back to John Ellis's initial point about what makes a good vaccine, right? Demonstrating measurable impact in clinical outcomes. Those studies require, the large population, large numbers of replicates, and in order to make them practically relevant, right? Then we're talking about large pen studies or large group studies. If you're going to In some ways, that's more accessible in the feedlot than it is in a cow-calf environment. So then, in order to do that across cow-calf environment, you actually have to do the same thing. Only you have to do the same replication, and so the difficulty in doing all of that is pretty large. So
Well, we
as an
do it for
epidemiologist,
metaphylaxis, right?
yeah, yeah,
I mean, we know metaphylaxis is highly effective, and I can show you and part of it's because of the FDA approval process, but there's a lot of new
well,
animal NADA research with a metaphylactic group versus a non-metaphylactic group within the same study population. And we clearly know how effective metaphylaxis is. We don't have that same type of research for vaccines for a number of reasons.
yeah. Part of it, though, too, right? So your comment about metaphylaxis, if you have a fivefold, 500% decrease in occurrence of respiratory disease related to like telathromycin versus a 1.5 or 1.25 relative risk difference for vaccines, it's harder to show that difference, right? So I
The
go to
effects are a
Amelia.
lot smaller, yeah.
I mean, Amelia's comment about data are out there on some of these, but they're done for proprietary reasons in cattle that are owned and managed. And so not all of those data are publicly available, right? In terms of what all of the research that's been done. Um,
I
uh,
think the effectiveness of metaphylaxis tells a bit of a story though too in these high risk cattle, right? What is antimicrobial metaphylaxis doing? It's controlling a bacterial disease, right? Which is the end stage of BRD, which is after the viral challenge essentially. So it kind of lends a story a little bit about the timing and the pathogenesis of BRD is that a lot of cattle are benefiting from control of the bacteria, which is the end stage of the disease at the time of arrival.
yep. It seems like we lost Dr. Ellis for just a moment. But we'll keep going here. Um, next question for John Richeson. Related to an idea of can we over vaccinate straight weaned ranch calves with 3 rounds of modified live vaccine prior, I'm assuming prior to the weaning, 60 days weaned, and they still get sick at the feed yard. Why would that happen? So they've had effective vaccination, they've had, sort of the optimal backgrounding experience, and they still have high morbidity events in the feed yard. What do you think about that, John?
Well, I do. I think our vaccines are very good at stimulating immunity. I think there's good antigenicity there. But I think that particular question nicely displays the complexity of the pathogenesis of BRD, that you can have good immunization against a virus, but that does not necessarily mean that you're going to have a resilient and a robust animal that's going to resist bovine respiratory disease complex, which involves stress. It does involve virus, undeniably, and also involves bacteria as well. And so I think vaccination is one piece of the puzzle, but to expect sterilizing immunity, 100% protection from BRD complex within our production systems in every well immunized animal is obviously, we see that all the time where cattle that are well vaccinated prior to arrival still get sick.
And Paul, if I may, I think it takes us back to that earlier question of, could there be things causing BRD that we aren't vaccinating for? That question, I don't know for sure, but I'm guessing those 3 times vaccinated cattle probably got a 5-way modified live viral and a Mannheimia, maybe with or without Pastorella, right? That would be the most common way people would sort of precondition cattle. So maybe they got into the feed and got infected with coronavirus followed by Mycoplasma bovis, right? And so they didn't even get vaccinated against those 2 things, possibly. And then I think now we can maybe bring up something we talked about in the panel too, which is then there's also the host response to infection. If we can't get sterilizing immunity to some of these things, maybe those calves did end up dying with Mannheimia in their lungs, but it wasn't the Mannheimia so much as their response to the Mannheimia. There may have been other things in their life, their previous history, their genetics, their epigenetics, how their genes were sort of expressed, that led them to have an excessive inflammatory response to Mannheimia. We think we're beginning to get some evidence that that may be the issue for some groups of cattle, at least.
Great. Welcome back, John Ellis. Thanks for your resilience in bouncing back on the call, because I'm going to hit you with another one. Okay. So, so the question is quote unquote prime boost real?
Well, that's
And you'll probably have to explain what that means.
well, exactly. That's part of the issue. Without going on too much into it too much, I mean, the idea is essentially to use 2 different routes of administration to make a better immune response. And so there's, from an experimental, research perspective, there's, over 1,000 papers examining this sort of an approach, and with different types of vaccines, different agents. And so from a theoretical standpoint, it's well substantiated. So the next question is, well, are there any data in cattle that indicate that it's real? And we've spent a lot of time over the last several years looking at prime boost for various, but mostly viral pathogens in cattle, and there seems to be a benefit to it. But the problem is it depends on the age, it depends on the type of vaccine. And so I think you have to examine it really with regard to each pathogen and each vaccine you're proposing to use. But I think generically the idea would be to prime mucosally early in life to take advantage of the getting around maternal antibodies and priming a mucosal response, and then boost systemically. So that's the way we've approached it in cattle. And there are published data in cattle that document the improved efficacy of that sort of an approach. But it all goes back to, the kind of thing we talked about at the beginning today, was giving multiple vaccines prior to weaning. And so it fits into that sort of a perspective as well.
So I am aware of anecdotally of circumstances where the same um, viral targets, I won't call them the same antigens per se, but the same targets, same vaccination targets are administered, both with intranasal as well as intramuscular vaccines at the same time, right? And
Correct.
is that how common is that amongst the panel, right? How common is that actually occurring? And do we think that that's not the same thing that you were describing, John? But
I don't know that there's any data that is. It's a good question. Is there a benefit to doing that? I don't know that off the top of my head. In cattle, there certainly we haven't actually looked at that, but I think there are some anecdotal reports that maybe the other John and Amelia are more familiar with.
It makes a lot of sense to me from if you have the thought process of immunological training, right? And the two different routes are kind of training the animal's immune system, I guess, a little differently. And so if you show that animal to give that animal two different antigen exposures, it's probably makes sense that they would have a more robust immune response and maybe have more protection down the road with that particular process than like two parenterals during pre-weaning.
Just to follow up on that briefly, I mean the thing to keep in mind, I think, is that it's really difficult to prime for a mucosal IgA response parenterally. I know of no data, even something that replicates systemically like BHV1, difficult to prime for IgA because of where it's produced, right? And where the antigen is going to end up. So that's something I think to keep in mind in terms of the potential benefits of maybe giving both vaccines together, or at least priming with a mucosal vaccine.
excellent.
I want to throw out, I think there are a couple of papers that showed, I think somewhat surprisingly, that an injectable vaccine could induce a later IgA response on the mucosal surface, but we don't have very much data on that. There was an interesting study where researchers used modified live parenteral vaccine and then looked at IgA to BRSV and found that following sort of a single dose in a 30-day-old calf um, with maternal antibodies, they did measure IgA in those calves that was higher than the negative control group. That was done with Pyramid, and I think maybe that work was done up at RTI. And then there was a really cool study that you guys I think are probably aware of, where the researchers used um, uh, Vista intranasally, so it was an extra label use of the vaccine. This was a situation where they gave it intranasally to calves in maybe a month-old beef calves, and then they either got the intranasal or didn't get the intranasal. And then at the feedlot, the calves were then either given a booster with intranasal or parenteral or given nothing at all. And then they were challenged with IBR. So it was a challenge study, really, but kind of set up sort of like a field trial. And they did measure some IgA in those calves that got the injectable vaccine, but not as much as the intranasal. I think that study with the sort of Vista intranasally showed that you could get really high concentrations of IgA, and that seemed to be related to decreased viral shedding. So the intranasal was better for increasing IgA and decreasing viral shedding. But then when they compared the disease in the calves to the calves that got the parenteral intranasal prime and the parenteral boost, they didn't measure any difference in the disease. Both those groups, the intranasal prime and the intranasal boost, and the intranasal prime and the parenteral boost, did better in terms of disease following IBR challenge in the feedlot than the other groups of calves. So, but it was a little bit artificial because it was a challenge study, not a regular clinical trial.
Interesting conversation. Yeah. Thanks, you guys. Last question that we're going to ask in the first part of our session, Q&A session, goes to Amelia as the first responder. Would a genomic study of incoming feedlot cattle to identify markers for resilience to acute respiratory disease be useful? And as a part of that question, or a second part of that, a related part, what would we how would we select for more resistant cattle? What would we select on?
Yeah, so that I think that question might have resulted from some discussion we had in the panel where we talked about there are some cattle that go through our flawed system and still do pretty well. They don't end up being treated for BRD. Sometimes we don't even see evidence that they get BRD. So could we start to focus research on those cattle? What is it about those cattle that allows them to stay healthy? And so a genomic study that I think the questioner is probably thinking about, could we look at the genes of these cattle as sort of a genetic study? And that might be part of what's going, what helps those cattle stay healthy. But there have been researchers that have tried to look for genes associated with BRD resistance, kind of as has been done for other traits that we're interested in. And my view of the literature, and people might debate this, but is that we haven't been able to find clear-cut genes that are associated strongly with BRD resistance. That if we selected simply based on the genetics, it might be hard to really get very far very fast because it's not certainly not a single gene, not very strong association with just the genetics. But I think we all have to remember that your genetics are modified by your experiences and by maybe even your mother's experiences when you're in utero. And this is where this concept of epigenetics, things that change your genome, then can change the way your genes are expressed, could be playing a role here. And I think there is a lot of room to look for that. So I think that what we would want to do, how would you do that, is to study systematically the cattle that stay healthy. And that's something that really hasn't been done. But you need to do it in large numbers of cattle, over some period of time to get an idea of whether there are repeated patterns, things that we can really pick up on in the cattle that stay healthy versus the cattle that don't. And I just want to say quickly, something we maybe didn't talk about much during the panel, is that when I say stay healthy, does that mean cattle that don't get treated for BRD, but they still have BRD? Or are we talking about cattle that don't have BRD at all? Because one of the problems with all this discussion about cattle that resist BRD is that it's still usually based on clinical diagnosis. And we know that we misdiagnose a lot of BRD. Some cattle get treated when they maybe don't have any lung lesions. Other cattle have lung lesions and nobody ever notices them as showing signs of sickness. So if we want to try to select cattle that stay healthier, we may have to pause for a minute and say, do we want to select cattle that can have pneumonia but don't look sick and still gain weight and never die? Or do we want to select cattle that don't get pneumonia? Personally, I would be more in favor of the latter than the former, but we need to kind of sort that out as we go forward trying to work on this.
Wasn't and I have to admit, I was trying to look on my computer real quick while we were talking, because when you were answering, because wasn't that a component of the large BRD study that a group out of Davis was a big part of, where they looked at BRD in calves?
Yeah, there was what we call a USDA CAP, Coordinated Agricultural
Yeah.
Project grant, about probably 10 or 15 years ago. And the researchers did look at the genetics of BRD, and they did find some evidence of heritability or genetically associated characteristics being associated with BRD resistance. But I'm not aware that that has continued.
And that's GWAS, right? A genome-wide association study in that. And your work that you have led and participated in with Matt Scott and others, you've looked at the transcriptomic response, and those are different, right? So maybe.
Right, there's that as well. Looking at the genes, the DNA sequence that doesn't change in the cattle versus the expression of the genes. And one way to look at expression of genes is to look at the transcripts, that is the messenger RNA that's transcribed off of the genes. And so that's something that you're right, Dr. Scott and I and some of our collaborators have worked on together. And it sort of suggests that certain gene expression patterns are associated with being more likely to stay healthy. So yeah, that is definitely one way we've looked at it. And I'm excited about some of the stuff we found, as many of you know, but I always have to kind of stop and remind myself, we've still only looked at about 200 cattle total, or maybe we're up to 400, because doing the transcriptomic assessment is expensive. And so we need to try to find ways to look at more cattle in a cost-effective way. And I do wish that we would get some more support for some of this kind of research. I think we have the potential to do a lot of pretty cool stuff, but it needs to be done in numbers of cattle that really give us meaningful outcomes. And so we need to find some consistent funding for some of this kind of research.
Another tool that's really exciting, I think, is the DNA methylation. And I don't claim to know a lot about it, but it's basically a fingerprint, like different experiences in that animal's life affects the methylation. And I think there really could be some correlations with it and BRD outcome. I think the really important thing, though, that Amelia mentioned is if we want to make progress and really try to figure things out, I think we need to consider doing things differently. And a big thing is, yes, we've always focused on the sick cattle. And I think someone, a researcher out there could probably make a lot of progress and find some really interesting things honing in on those animals that don't get sick, although their cohorts do, because we've really never invested much time and effort in evaluating those types of animals. And unfortunately, in a lot of high risk cattle populations, those are the minority animals, right? I mean, the majority of the group would end up getting affected by BRD. So what is it about those 10 or 20% of animals in super high risk populations that stay robust through that whole process?
Right. Okay. If the group's okay, then we'll go ahead and close up our part one of our Q&A session on this. I want to thank all of our panelists for their time and for their expertise in this. So stay tuned, though. There is part two, and so make sure you come back and watch that as well. Thanks very much.